Hello, welcome back to Python Challenge for All. Okay, so last time, yes, lesson 77, I showed you how to solve 8 puzzles. Yeah, right. I think you have mastered the art of solving any 8 puzzles, any solvable 8 puzzles. Okay, then what's next? Today's topic is actually, you might wonder if what happens to 15 puzzle games. Okay? Yeah, as a natural extension of 8 puzzles, we have bigger sliding panel games, which is 15 puzzles. So, before going on to automatically solve 8 puzzles, let's think about the solvability of 15 puzzles. Okay. Actually, let's play with the 8 puzzles first. Let's change our 8 puzzle to 15 puzzles first. Okay. So okay, let's go back to our code and see. Save file as what's the 878? Okay. So EL78. 15 puzzles. Okay, puzzle 15. Okay, this is fine. So let's see if we can change this to 15 puzzles easily. So let's change NN to 4. And then maybe we can change the size to say 20 times 4 is 80. So maybe we should change this to 80 and 90. Also, the title is 15. And I think other parts are okay. Let's hope this will help enough. Another point we should change is message position. So this should change to 80. Okay. And also this should change to 80. Okay. Let's see how it looks like. Great. Okay. Now it's 15 puzzle. And also we can move this as we like it. If we click the panel next to the empty box, we can move it as we like. So, is this good enough? Actually, no. Let's go back to the slide. So it's working, fine. What is the solvability condition for 15 puzzles? Okay, we checked in 8 puzzles, inversion parity is the only condition. Because if we change, okay, we print it here, the after each move, we printed the value. Okay, let's see what's on the display. So if we move panel, okay, here, step and inam. Okay, so inam, the new point here is, okay, let's see it. Let's see the difference. Okay, in case we change this back to 3, which is 8 puzzle, you see, if we move the board, the parity here, 10, 12, 12, 14. So it's always even, which we found to be true last time. Let's change this to 15 puzzle by changing and see what happens to this number. Okay, if we click 14, 24, 24, fine. But if we click here, now it's 27. Now this number changed from even to odd. Okay? And if we move horizontally, the parity doesn't change. But if we move vertically, you would change the parity from odd to even, even to odd, odd to even. Okay? So this is a trick we have to think about when we see the solvability of 15 puzzles instead of 8 puzzles. So in 15 puzzles, actually, vertical distance of 0 also counts. So yeah, maybe if you search in the web, you can find out why. But this is what we should know about. So vertical distance of 0, which is empty panel, counts. Okay, let's try it to see. If the empty panel is 1, the goal position of the empty panel is here. So it's one panel different from the goal position. So it should be, okay, every time we move vertically, it changes this parity. So we have to take this in mind. So let me define a new function which counts the vertical distance, okay? Vertical distance means the distance of the empty position of from the goal position. So, okay, let's define a function div, say row difference. Row difference, and given board, we can check return. So actually, nn minus 1 minus board index 0. So this is the position, vertical position. This is the index of the empty box. And if you divide, yeah, divide by nn, you can change it to the vertical distance, vertical index, y position, y coordinate of the panel. And you change, if you subtract it from nn minus 1, you can have the distance from the goal position. So, okay, let's move this and check what happens to this value every time we move. So maybe rdiff equals rdiff, row diff, self board. For future use, so we can go back and forth from 8 puzzle to 15 puzzle. Let's write this way. If nn is even, then it should be 0 all the time. Else, row diff self board should give the answer. And so let's print it. Okay, so let's print it as rdiff. And believe me, it should be decided as inam plus rdiff instead of just simple rdiff, inam. That's the way we can decide whether a problem is solvable or not. For our checking, let's print instead of just inam per rdiff to see if every time we move, observe the parity of the sum of each move panel. Okay, so instead of just inam plus rdiff, and see if this maintained its parity. Okay, let's try this. Okay, so here we have okay here. So it should be solvable. Okay. Invenam is 39 and rdiff is 1. So the sum is even So it should be solvable. And if we move the panel, oh, our diff is not row diff. Oh, sorry. I should have that calculation here too. Okay, here instead of just, okay, yeah. In addition to calculating infinitum, also calculate rdiff each time. So let's run it. So here, okay, and horizontally, it's even 46, 46. And even if we move it vertically, it remains even. Okay, so now, whatever movement we make, the parity of the sum remains the same, even. And this is how we can reach the goal. When we reach the goal, okay, see, let's lastly, let's see if the number is the same for the correct one. So the goal position is can be given an range. Yeah, it's like this. Okay, so the goal position must be range 1 to nn times nn minus 1 plus 0. Okay, this should give the correct goal position. Let's take a look. Oh, sorry. List. We should have list here. Okay. List range 1 to say for 14 plus 0. Okay, 15 plus 0. Okay. What's wrong with this? Oh, there's no minus 1. Okay. So this should give the goal position. So this time, okay, you see the addition is 0, 0, 0. So if we move it horizontally, 0, vertically, 4, 8, good. So now you can see the parity is always even, whatever movement we make. So naturally, we can lead this to go back to the goal position, which is what we want. Okay? So I think this is good enough. Yeah, I don't do that. But anyway, so let's move it. So starting from the goal position, it's good. Okay? Now the parity is always the same. So this is the key to the rule of 15 puzzles. Now we have both 8 puzzles and 50 puzzles working. So let's enjoy puzzle solving. Yeah, let's try that. Hope you can come back. Bye bye.